Welcome to UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at software engineering. For today's session, I will be continuing on the agile software development methods. In the previous session, I was talking about Scrum practices, whereby we may have to come out with burn down charts. So for every sprint, we will be planning on burn down charts. These sprints are assigned as simplest tasks, so that will be effectively converted into man hours. Say for example, code for user interface totally requires 20 working hours, that is assigned as 8 hours on Monday, 4 hours on Tuesday and 8 hours on Wednesday. So to work on this, Monday I am supposed to parallelly work for approximately 44 hours. So that is why on Monday 44 hours. Tuesday parallel tasks are being taken for say 32 hours. Parallel tasks are given concentration on 34 hours. Parallel tasks being taken up for 18 hours and 8 hours. So by where I am to ensure, because of this burn chart, all these tasks that are parallelly being considered are to be brought completely to zero at one point in time, that is well estimated to be within the time frame. So to give a finishing touches, the overall Scrum practices or the Scrum process will be something like this, where initially I will be getting the product backlog, which is given for a planning, then will be converted as sprint backlog, which will be the input to the sprints. Once after every sprint is complete, it will be taken for review, then it has been considered for potentially shippable product towards increment. If the concentration of the review, or if the decision on the review is on the other side, that is it is not as incorporatable with the features as possible, then the review decision is carried forward again to the planning phase and it repeats. So this is for increased team capability. I do a retrospective work, and retrospective actions are being given as input to the sprints at every delivery. So there has been two major deliverables that would happen. One is on the product deliverable, the other one would be on the capability deliverable. So capability deliverable would be on looking at the capability of the entire team or the person who are working on that particular team, which will basically do an iteration and try to identify what add-on features that the project can take. And the product deliverable repeatedly talks about how to effectively work on the product, give it as an efficient work. The other method towards this agile methodology is called dynamic systems development method, which is DSDM. This DSDM predates the Agile manifesto. It is a management and control framework for rapid application development. So with the traditional software development lifecycle model, we would have seen an approach called rapid application development model, which would work given a limited time frame, say 60 to 90 working days, maximum 3 months. So this DSDM works for similar to those control time frame. This rapid application development model aims to build working system rapidly. Prototyping model aims to build a systems quickly. Similar development environments can be used for both. A prototype may incrementally become a working system. So what could be the origins for this dynamic system model, development model? RAD, which is rapid application development model, became popular in the early 90s due to various deficiencies that was encountered in the waterfall lifecycle model. The deficiencies majorly projected in the waterfall lifecycle model would include: all the requirements are to be clearly defined before it gets completely moved to the design phase, so which may not be possible. So this one of the deficiency is being rectified in the rapid application development model. So this DSDM got created in 1994 to define the structure and controls for the RAD project, and it does not specify the development methodology, and it has been used with a standard structure development model which actively takes up object orientation also into its practice. Talking more about this DSDM, DSDM takes a radical perspective on the project control. Historically, requirements are fixed while resources are allowed to vary. DSDM fixes resources for the project, that is within the time frame and within the budget, then only delivers what is to be achieved within these limits. So the latest version of DSDM is based out of 8 principles. Principle number 1 focuses on business need. What is the need for that particular day in terms of the business will be looked at. So fitness for the purpose is essentially being tested for all the products. Focus is given for delivering within the time. So the deadlines are never sacrificed for low priority requirements. Collaborate. In DSDM, all stakeholders are important, including end users and resource managers. DSDM never compromise on the quality. So for this reason, testing is integrated throughout the life cycle along with the customers, and it develops iteratively, allows the project to converge on accurate business solution. Build incrementally from firm's foundation, where the partial solutions are not acceptable if they satisfy an immediate need, and this encourages feedback from users. Communicate continuously and clearly to the customers or to their own team developers, and to project an overall demonstrable end version in a controlled format. This is the life cycle of DSDM, where a pre-project with forward paths through the process is given initially for feasibility study. The foundations of the project is being explored, engineered, deployed. The advantage being every phase is repetitively or retrospectively being taken up, and the post project is being conceived for later purposes. So there are iterative process that would happen both in the forward fashion and in the reverse fashion. This DSDM life cycle has got 7 phases. One is on the pre-project, feasibility study, foundations, exploration, engineering, deployment, and given for post-project. So we can make an appropriate study based out of DSDM project life cycle, how these business application would be helpful in today's real world applications. So as far as feasibility is concerned, being the first of its kind in DSDM, it determines whether the project is suitable for DSDM. Typically lasts only 1 week. Should also address the following questions like: is the computerized information technically possible? Will the benefit be outweighed by its costs? Will the information system operate acceptably within the organization? So these things are initially being studied as a feasibility analysis. Then we will look at the foundations towards working on this project. So the basic foundations of DSDM model include: it identifies the overall scope of the project with results in agreed high level functional and non-functional requirements. It maintains objectives set at this stage, determines the quality, maintainable from the initial operation, not necessarily maintainable when first installed, but this can be addressed later also. Short lifespan system that will not be the subject to maintenance. After the foundations are clearly understood, then it is the possibility of taking it for exploration. That is, foundations are supposed to be the basic spec every project should have. Then we make an analysis, detailed analysis on these foundations, which is supposed to be your exploration. So we may have to develop prototypes to elicit detailed requirements. They may ultimately be delivered as operational systems for operational use and non-functional requirements. This includes analysis model as well as prototypes. Once after the complete of exploration is complete, then it is to be technically engineered. For engineering, we consider the prototype developed to the point where they can be used operationally. Distinction between exploration and engineering is not been clear cut. Project may move back and forth between these phases over several iterations. After it has been engineered, it has been given for development purpose. So engineered is basically like a design that we encounter on a development life cycle model. So now it has been given for development purpose, where we install latest increment and train the users, review how well the requirements have to be met, and may return to earlier phases like to engineering to complete functional and non-functional requirements. If those are found to be not complete, maybe we can go back to the engineered phase. We will look at what has not been addressed with and then come back for the development and work with. If suppose it has not been studied at the foundational level itself, it can go back to the exploration phase and go back to the foundation phase, get all those details, and it can flow through on a forward path. Finally, it can be untestable. To foundations, if a new functional area has been identified, any new functional area which is conceived as a new increment can also be incorporated now. And further, it restricts itself within the time. So time boxing is also being taken care. It fixes resource allocations for a project or to a part of a project. It limits time available for refinement of requirements, design, construction and implementation as appropriate. So these terminologies like requirements, design, construction and implementation are majorly being used during rapid application development model phase. So each time box has a set of prioritized objectives which are clearly defined. So each time box produces one or more deliverables. So as far as deliverables is concerned, for every time box there cannot be only one deliverable, so it can be more than one deliverable also. So within a time box there are three main concerns: investigate what needs to be done in terms of determining the work, develop and refine the specified deliverables, consolidate the work prior to final deadline. So this is how we do a time boxing work, where we have the major phases like investigate and set the objectives, produce deliverables, consolidate the work done. So this is for one time frame, this is for second time frame, and this would be for the other time frames. A time box has three phases, each with different focus of attention. So each is of different focus. A time box occurs in an overall sequence of other time boxes. So this is time box 1. This happens in sequence with the previous time box. This happens in sequence with the previous time box. So activity within each phase is iterated as necessary. So once when the foundations have been investigated, if we are not about to set a clear objectives, we can iterate on those investigation again and again. Likewise, for product deliverables and consolidating work done, it can be iterated on a repetitive manner. So the end of a time box is an absolutely inflexible deadline, and most of DSDM practices follow through a set of rules which is called Moscow rules. This Moscow stands for must, should, could, want, specific rules. So it is basically a heuristic which helps to prioritize all the requirements. With must, it should have all the requirements as crucial. With should, all the requirements are important. With could, it should have all the requirements less important with want to have but not this time around requirements can reasonably left for development in later increment. So when you look at rapid application development model and DSDM in parallel, RAD type of model concentrates ADCT phases sequentially within a span of 60 to 90 working days, whereas DSDM model concentrates on agile practices with a typical practice of what requirements that are to be at most required or what features are to be taken which are essential for the application to be developed, what requires are important that are to be considered, and what is less important which can be taken up for later stages. So this is a very important step that we may have to do while we are working with DSDM. Going again with the Scrum practices to highlight on a framework for developing complex products. Unusually, Scrum is not an acronym, it derives from, as I have mentioned, the game rugby. In Scrum, people are either pigs or full team members. Say for example, the complete of 9 members who are actively participating, or chickens, everyone. Some chickens can specify a product, but no chicken can tell a pig how to do their work. So there is a Scrum Master. Scrum Master is not fixed. The team members are fixed. So Scrum Master, a person who is acting as Scrum Master for a particular day need not act for the second day. So that is what this particular slide mentions. To talk about Scrum framework, this mainly consists of roles of the people, time boxes which is considered from the DSDM. So this is how I map DSDM with Scrum. So Scrum mostly takes us burn down chart and time boxes. This time box is being incorporated from DSDM practices, and it produces artifacts or it is used by the team, sets rules about who can do what. Scrum neither has a defined life cycle, although it does insist on iterative approach. So to look at the different roles provided by the Scrum, team members do the development work in whatever way they think the best that they could provide. Scrum Masters are supposed to be the best motivators or the coaches to ensure that the Scrum rules are being followed in terms of conducting regular follow-up, stand-up meetings, Scrum meetings, etc. Product owners has the power to decide when an increment is done. In case I am to add more set of features, whether it should be during the product backlog or whether it should be during the sprint backlog, that could be provided by the product owner. These roles are only pigs, all others are chickens. Scrum time boxes. As in DSDM, all work iterations and meetings are time boxed. Required meetings include sprint planning meeting, daily Scrum meeting, sprint review meeting. And these are known as Scrum ceremonies. These meetings punctuate that each sprint, that is between 2 to 4 weeks work iteration, we get an end product delivery. So some of the Scrum artifacts include 4 key artifacts are continuously updated as the project proceeds. One is on the product backlog, where we set priorities for the list of requirements maintained by the product owner. Release burn down, which is a graphical estimate of total work need to be complete in the due course of the project. Sprint backlog and sprint burn down, which are similar but applied to the current sprint, which is happening between say 15 to maximum 1 month period. Some of the standard rules that we may have to follow while practicing Scrum include: Scrum teams are self-organizing and no formal leader is imposed. As I have already mentioned, Scrum Master is not a formal role assigned to a specific person. Only pigs can talk during the daily Scrum. Chickens cannot tell pigs how to do their work. So the Scrum Master can just motivate from the other member in the team, initiating other member in the team, making them talk, Not that the Scrum Master alone will give ideas. Only the product owner can define what it means to say that the increment is done. In continuation of these agile practices, there are other agile methodologies like Crystal, feature driven development, adaptive software development, which are also being practiced. But most majorly, if you look at software engineering industries, IT based industries, if it is always been safe that if they flow through waterfall model only when they understand the requirements well ahead in time and in the initial stages itself. It is basically because it follows the traditional platform of analysis, design, coding and testing. Whereas all other methodologies are not as traditional as it is, whereas conventional methods like agile practices follow a different setup. Some of the challenges these agile methods face are undefined goals, where features are more dominant or user stories are more dominant, and never ending project with overruns. So there are projects which are to be continuously being developed over different increments. So these kind of projects will surely overrun on the cost and time frame. So these agile methods require clear, single, invested customer. There cannot be partners of a customer who can actively participate. One or two members, if they participate, then it becomes a chaos. These agile practices are of all or nothing type, mostly of autonomous adoption of techniques. Some parts work only if lots of other aspects used. And these agile methods can work better only with small team size. Basically, to talk about the concept map of these agile principles that we have studied so far. Agile is basically giving us an intention on welcoming change. It provides a complete customer satisfaction. We can build individual self-organizing team. We can give continuous attention to detail. We can provide working software. We can look at the measure of progress, focus on individuals, regular adaptation. It motivates face-to-face conversation because of collaborative work. It encourages sustainable development which maintains constant speed. It encourages close cooperation and defines simple rules. So these are some of the energetic activities around agile principles that makes today's generation of projects more encouraging. During 90s and 2000s, when people were developing projects, they were adopting to traditional software development models, by where they were not very comfortable with flowing through a regular phase of analysis, design, coding and testing. But through these practices, the hierarchy within the software development firm is being avoided. So now that having introduced few members like Scrum Master, Product Owner, team members, where there can be active set of collaborations by drawing burn down charts, by having regular sprint meetings, by having regular stand-up meetings, which encourages all the team members in a routine manner. And over a short lifespan, we are about to deliver a product or a simple feature of a product or a user story, which also activates all the team members and showcases how effective they are in front of the customers. In summary, in this lecture, you have learnt about some of the characteristics of agile software development. Over these phases or over these parts of lectures, we have looked at traditional software development methods, and in the previous few lectures we have seen about agile software development methods. And three key features leading to agile methodologies like DSDM, Scrum and extreme programming. So these three that are the major things that industry adopts. DSDM is something similar to rapid application development model. Scrum practices are majorly being used in opposition with waterfall model, and extreme programming is equally being practiced. Thank you.